Imagine that you have n natural numbers that are all stored inside an array. Each number appears exactly 2 times in the array except for a single number that only appears once. So the length of the array is 2n minus 1. Your task is now to find a unique number in linear time. This means that you cannot simply sort the list since comparison-based sorting is in time O of n log n. Further, you cannot use a hash table since they use randomness, and we want something very simple that also works if the whole universe conspires against you. Your approach should work inside the RAM model. We assume that our n numbers are all between 0 and n to the 3 and are stored using 6 log n many bits. Further, the following operations can all be performed in constant time: reading and writing a value, looping or branching, basic math operations like addition, multiplication, subtraction, division, and modular arithmetic, comparison operations, bitwise operations like bit shifts, negation, and or XOR. Note that taking a bitwise operation of 2 values simply means that we apply the operation to each pair of bits individually. So the RAM model is very close to normal programming, where we assume that each basic operation takes constant time. But can you find the unique number in linear time using this model? The answer is right before our eyes. To find it, we use the XOR operation. As a quick reminder, XOR outputs 1 if the 2 inputs disagree and returns 0 if they agree. Now, XOR has 3 very useful properties. First, XOR is associative and commutative, meaning that we can arbitrarily rearrange the elements whenever we compute XOR. Second, the XOR of a value with itself is always 0. To see this, simply observe that each value agrees with itself on all bits. Third, XOR of 0 with an arbitrary value x is always simply x, because whenever the first entry is 0, then the output is simply the value of the second entry. Now, what happens if we take the XOR of all values in A? By our first observation, we can reorder them in an arbitrary way without changing the value. So for example, we can always group together the 2 duplicates. Now, our second observation ensures that each pair of duplicates just cancels out. Therefore, by our third observation, the only element that remains is the unique element, since it does not have any duplicate. Hence, we can use this very simple algorithm to find the unique element in linear time. Pretty neat.